Hey everyone, we're going to look at the first two in section 5.5, numbers 1 and 2, and they both have the same directions. Find a formula for the function represented by the integral. And here's the one for number 1, at least the one that I have. Again, your numbers might be slightly different, or the expression even a little bit different that you're integrating. So notice we're integrating the function u squared. Notice the variable of integration is u. So we're just going to use fundamental theorem of calculus part 1. And we're going to find the antiderivative, plug in the upper limit. Notice the upper limit is x, lower limit of 2, and we're going to subtract. We're going to end up with a function of x, right? And that's the formula that they're wanting you to express. Pretty easy then. The antiderivative of u squared is 1/3 u cubed. Notice we're evaluating it. Remember, we write this evaluation bar at the upper limit of x, lower limit of 2. Plug in x, I get 1/3 x cubed minus, plug in 2, 1/3 2 cubed. 2 cubed is 8, and so here's my function. This is the function of x that they're wanting. Maybe we can call that f of x, but that's the function that they're wanting. Okay, and if you recall, we talked about this in classes. This function is sort of the area function or area accumulation function for the function u squared as we go from 2 to whatever x is. It's accumulating that, well, that signed area. We should emphasize the signed area. Okay, let's look at number 2, which is find a formula for the function expressed in this integral. So here we're integrating sine of 10u, and again, your function might be a little different than this, might have a different number than 10, for instance. And we're going to find the antiderivative of that function and then plug in again x, plug in 0, subtract, and we'll have our function. So what's the antiderivative of sine of 10u? So you should know the antiderivative of sine of u is negative cosine of u. Now, does that mean the antiderivative of sine of 10u is negative cosine of 10u? No, because by the chain rule, when we take the derivative, the derivative of negative cosine of 10u would be sine of 10 times u times the derivative of the inner function 10u, which is 10. So what do I need to do? I need to have that factor of 1/10 in front of this for me to find the antiderivative, right? We talked about this. Basically, we're doing what we call a little substitution. You can do it formally with substitution, but this is essentially what we need. Because if I take the derivative now of cosine of 10u, I get negative sine of 10u times 10. And so the negative 1/10 will give me just the sine of 10u. Okay, plug in x, I get this, right? Replace u with x, and I get that. Plug in, and then minus, notice in parentheses, negative 1/10 cosine of 10 times 0 would be 0. So cosine of 0 is 1. So be careful here. This is negative 1/10, but I'm subtracting it, so it becomes positive 1/10. So I've got negative 1/10 cosine of 10x plus 1/10. I just changed the order that I add those two in, so I wrote that as 1/10 plus a negative 1/10 cosine of 10x, or just 1/10 minus 1/10 cosine of 10x. And this would be fine as an answer. You could also write this as a fraction this way. I think this is what I saw in Achieve's answer. I hope they take this as well. You can even combine this as 1 since the denominators for both of these fractions is 10. You could write it that way. I'm good with any of these forms. You could even write as negative 1/10 cosine of 10x plus 1/10, just a different order here. Okay, hopefully this helps for the first two in section 5.5.